Hello students, in this video we are going to see network layer protocols and introduction part. This topic is also from unit 3. Here we can see various types of network layer protocols. We also show how the network layer is implemented in the TCP/IP protocol suite. IPv4 is an unreliable datagram protocol, but it offers a best effort delivery service. The term best effort, what we mean here is that IPv4 packets can be corrupted, be lost, arrive out of order, or be delayed and may create congestion for a network. If reliability is important, IPv4 must be paired with a reliable transport layer protocol such as TCP. We can say post office as an example for this IPv4. So in this picture we can see that IPv4 datagram format. So as we know that it is 32 bits protocol, the header contains 20 to 60 bytes. So the whole data is 20 to 65,536 bytes. We'll see this one by one in the next slides. Datagram format. Packets in the IPv4 layer are called as datagrams. A datagram is a variable length packet consisting of two parts, header and data. The header is 20 to 60 bytes in the length and contains information essential for routing. The first block of this datagram format is version block. A version or VER, this is the 4-bit field defines the version of the IPv4 protocol. For this one, that is for IPv4, currently the version is 4. However, if we are going to use IPv6, then the version block will contain the value 6. So totally, the IP version 4 will be replaced to IP version 6 in future. The second block is header length or HLen block. This is a 4-bit field defines the total length of the datagram header in 4-byte words. This field is needed because the length of the header is variable between 20 and 60 bytes. Services block. IETF has changed the interpretation and name of this 8-bit field. This field previously called as a service type and now it is called as a differentiated services. Service type. In this interpretation, the first 3 bits are called as precedence bits. The next 4 bits are called as a type of service bits. And the last bit is not used and it is reserved for the future purposes. Precedence is a 3-bit subfield ranging from 0 in binary to 7 in binary. The precedence defines the priority of the datagram in issues such as congestion. If your router is congested and needs to discard some datagrams, those datagrams with the lowest precedence are discarded first. Type of service bits is a 4-bit subfield with each bit having a special meaning. Although a bit can be either 0 or 1, one and one of the bits can have values of 1 in each datagram. For example, ICMP protocol may have the service type of service bits as 4 zeros and the description is normal. Boot P protocol can have a type of service bits as 4 zeros as description normal. Likewise, each and every protocol can be assigned with the type of service bits as shown here. Next block is the total length block. This is a 16-bit field that defines the total length including header and data of the IPv4 datagram in bytes. To find the length of the data coming from the upper layer, subtract the header length from the total length. The total length field defines the total length of the datagram including the header. Identification, flags and fragmentation offset blocks are the fields used in fragmentation that we will be seeing in the next slides. Now, time to live is the next block where a datagram has a limited lifetime in its travel through an internet. This field was originally designed to hold a timestamp which was decremented by each visited router. The datagram was discarded when the value becomes 0. Next block is the protocol block. This is an 8-bit field defines the higher level protocol that uses the services of the IPv4 layer. An IPv4 datagram can encapsulate data from several higher level protocols such as TCP, UDP, ICMP, and IGMP. This field specifies the final destination protocol to which the IPv4 datagram is delivered. For example, if the protocol is having the value 1, then it is ICMP protocol. If it is having the value of 2, then it is IGMP. If it is having the value of 6, it is TCP, 17 for UDP, and 89 for OSPF. The next block is the checksum block. A number is added to each and every data which is being sent in the network to verify that the data which is sent is actually received. Next block is the source address block. This is a 32-bit field defines the IPv4 addresses of the source. This field must remain unchanged during the time the IPv4 datagram travels from the source host to the destination host. Next block is the destination address block. This 32-bit field contains or defines the IPv4 addresses of the destination. This field must remain unchanged during the time the IPv4 datagram travels from the source host to the destination host. The last block is the options block, which is used for the future purposes. Fine, we have come to the end of this topic. We will see the next topic in the next video. Thank you.